Good morning, good evening, everyone, and welcome to our session today. My name is Nidhi Chappelle. I lead the product team here at Azure HPC and AI. And today I'm excited to talk to you a little bit about how you can unlock your innovation using our platform. This is our very first Azure HPC AI day. So first off, welcome for this. I know there's a lot of events that you are being asked to attend. I hope today you're able to get a good sense for what kind of innovation is going behind the scenes in our platform, and you get a good sense for the capabilities that we bring to the table. Our hope is that going forward, we can make this day an annual event. So this will be our good way of connecting with you at a regular cadence. As I look through the events of our world today and over the last few decades, it behooves me to realize that as a society, the problems that we are facing are becoming larger than ours and more complex than anything we have faced in the past. This is the moment where we need to equip ourselves with the power, skill, and intelligence necessary to overcome these problems. Physics-based HPC models continue to enable new breakthroughs that have furthered the frontiers of science. And in the last decade, accelerations in AI research have allowed us to glean insights from data that was just not possible before. Here at Azure, we believe that combining these two disciplines is the key to unlocking the biggest challenges that we face today as a species and as a planet. We are honored to be in a position to lead this new era of intelligent solution development for our customers, with our customers. And today, at this Azure HPC AI Day, I hope I can equip you with some of the tools, knowledge, and inspiration to drive favorable outcomes for your particular purpose. As we go through this discussion, I want to walk you through how our approach to Azure, especially our focus on HPC and AI, has been focused on delivering leadership that really is focused on developing and delivering a platform that is not a vanilla cloud. It is a differentiated experience. It's authentic to the needs of the customers and is very centered around the experience of our customers end to end. Today, you will get to know our approach to this. And really, this is where we differentiate ourselves. I take a moment to explain how Azure has invested in HPC. I would say that we've taken a very differentiated approach from the beginning. Our competitors have spent a lot of marketing dollars trying to prove to you that you can do high performance computing on vanilla cloud. We actually don't believe in that. We actually do think you need the right tool for the right job. So our investments in Azure have focused very much from the beginning on getting the right talent so we can understand and develop a deep understanding of the workloads. Based on these investments in talent, we've actually come up with purpose-built infrastructure that is highly optimized for both scale-up and scale-out scenarios. We have different sets of offerings that are focused on throughput-oriented HPC or MPI-dubbed HPCs, or for AI training and for AI inference. Our breadth of offerings allows us to not only deliver performance that is on par with what you have on premise, but actually surpasses in many cases. We work very closely with our hardware vendors, whether it's x86 vendors like NVIDIA, like Intel, AMD, ARM vendors, or GPU vendors like NVIDIA and ARM to make and AMD to make sure we can deliver performance that actually is on par and better on our infrastructure. Some of these examples you have seen with us being time to market with the recent launches, such as our offerings from AMD, Rome, Milan, and then Milan X. Our goal is that when it comes to technology, we offer a very differentiated solutions for your applications based on the tool sets that you're already using today. And all of that optimizations is things that you don't have to worry about, and that we take care of it in the background. So what you can do is take the capabilities that we provide and use them to have faster times to decision, more simulations, or really anything that accelerates your research, your users, and the work they are doing. You will see that we actually offer a breadth of offerings from all sorts of workloads, highly tuned for those workloads. Over the last few years, Microsoft has made very significant investments in HPC. This is just a quick snapshot of just the last 3 years. And if you look through this, I call this our brag sheet, but really the goal here is we've focused from the get-go on breaking what is possible in cloud, being the first one to showcase that you can really do a typical HPC job, 80,000 cores, 90,000 cores. This does not give us pause. This is exactly what we think our customers are running on premise, and we want to showcase that on cloud. So from the get-go, we have invested in InfiniBands, in having the right level of storage system, having the right level of bandwidth, so we can make sure applications that are memory bound, memory bandwidth bound, are actually getting the best performance. We are the only cloud service provider that has been on the top 500 list. In fact, just if we look at the last snapshot from November last year, we were among the top 10 supercomputers and also number 2 in ML perf results, right behind NVIDIA. And these results are actually now available for all of our customers. I call ourselves providing supercomputers at your disposal at any given time. So what does this mean? Really, from a customer point of view, as we see our customers looking at supercomputers, they start to look at cloud as a way to complement first, as their needs start to increase, whether it is, there is a new regulation that came up, there's a new use case, or really a need to increase collaboration across different engineering groups. Our customers start to expand beyond their on-premise. They start off by looking at burst use cases outside of their existing data center services capabilities. That's when they start to work with us. But pretty quickly, they realize that they can actually migrate that application onto cloud and actually, in many cases, get better performance, high scale, faster for their end customers than they could do it on premise. And pretty soon, they realize that their skill set is not in managing data centers, but in really optimizing the applications for the end customers. And this is where we work very, very closely with our customers to make sure we can help them in whichever part of the journey they are. Ultimately, our goal is really to optimize the experience that the end customer has, the researcher, the geophysicist that is at the end working on the science problem and does not need to worry about the infrastructure behind it. In many of these cases, we end up enabling new use cases or enabling new scenarios that were not possible before, or just taking the existing scenarios and scaling them pretty quickly. Today, I'm excited to share one of those examples. I'm joined by Nelson from Cibc. Cibc is a Canadian bank. It's federally regulated and has 55,000 employees. Cibc has been on a journey with us for the last 4 years, and they recently announced deeper partnerships with Microsoft. We're in the midst of migrating many of their applications from on-premise to Azure. As we do this migration, Cibc has been able to use our Azure DevOps to deploy Azure infrastructure that guarantees them security, quality, reliability, and compliance. There are many of their tier applications that are already running on Azure, including their web applications, mobile banking, as well as some of their capital market systems. Today, I'm joined by Nelson, the CIO from Cibc, to talk about their experience on Azure and what they have discovered as they transition from on-premise to the cloud.
Thank you very much, Nidhi. I genuinely appreciate you having me here today, and I appreciate the ability to speak about Cibc's path to fully leveraging Azure HPC. Before I begin, I'd like to set a bit of context. The unfortunate events in Eastern Europe today are adding to what is genuinely an unprecedented need for scenario analysis. We more than likely will run more analysis today, so more metrics and more computational resources than in any given month in 2018. So that speaks to the scale and the growth, and it's just something that we would not have been able to accomplish if not for the partnership with Microsoft and the work of many talented individuals, both within Cibc and within Microsoft. So quickly, I will move to a history lesson, and I am not sure how to get to this slide. I don't know that it made it into the deck, but in any event, in 2012, we were in a position that I would, characterize as typical of large financial institutions, where we knew that we had to run a distributed framework in order to be able to meet the needs, primarily risk needs. But the 2008 crisis had told us that we were, very much unprepared from a credit perspective. So what did that look like? It looked a lot like spending a significant amount of money procuring servers, and those were primarily, quad-core, dual quad-core servers at the time. Then buying licensing to stitch them together and running them at full capacity for 10 to 12 hours a day, and then having them sit idle pretty much the remainder of the day. And despite some work to become more efficient in that regard, there were limits to what could be achieved. Fast forward a bit to 2015, and I mean, this was my first significant partnership with Microsoft at that point, and we spoke about migrating that to HPC, so a built-in component of our Windows servers. And we accomplished that actually in a really short period of time. It was about 4 months, which had two benefits primarily. One, certainly a costing and licensing benefit. So we were able to take many millions out of our run rate. But then in addition to that, allowed us to harvest other Windows capacity that we had around the firm. So we probably achieved a 20% uptick in some ability to burst. But what it really did is told us that there's a very different and better operating model. We began to experiment 2016, 2017. Admittedly, it was with a firm that was not Microsoft. And we made some quite good strides. But as we reached the end of 2017, there were just some roadblocks that we knew we weren't going to get around, or at least not get around easily. And it was a fairly faithful meeting that I remember well. So I'm going to mention someone, Tara Johnston. Her and I met at like 7 p.m. on a Monday or something. And I posed a challenge to her to say, well, could you do this? And she organized a group of people. And within the week, actually, we began to work on, at the point, we knew three things. Number one, that this construct where we run front office analytics and risk analytics was something that was highly inefficient, and we could do significantly better. Secondly, that with FRTB, and hopefully some people know what that means, but it's effectively a revision of the way that market risk is generated. There would be as much as an 8-fold increase, and that's a systemic event as opposed to an organic event. But there would also be organic growth. And then lastly, that the feature sets within Azure would allow us to progressively uptick functionality. And we're seeing a rollover about every 6 months of new functionality. So, those were kind of the three criterion. We had a small group of people. I mean, this wasn't a massive working group. I think there were 3 or 4 on the Microsoft side, probably the same-ish amount on our side. And we concluded the work in May of 2020, but I'd say within about 3 months, we already had some very, very, very strong feedback, and it was obvious that we were on the right path in that regard. So again, just to provide a picture of, where do we sit today? So, this graph is intentionally not to scale. But again, 2012 with Data Synapse, fairly large and static cost base. Similarly, the runtimes could be manipulated through procuring additional machinery. But really, you're looking at a very substantial increase and absolutely no ability to scale down. HPC bettered that, so we achieved some capacity, we got some cost savings, but again, we were still running roughly the same level of metrics. Move forward to today, and really, I characterize the period of COVID onset in March of 2020 to present, where we just really ratcheted up the types of things that we're looking at on both a overnight/static basis and a real-time basis. So we've seen close to a 10 times uptick in the metric that we run. But you'll see in the first two, the 2012, 2015 bar charts, there's a little sliver of cores, and that number actually represents roughly 2,500 or so. And again, with HPC, we could go up to about something like 3,800, but that was kind of the limit. We now routinely exceed 100,000 every night. So despite that near tenfold increase in the metrics, we've shortened our runtime to about an hour and a half, and that's combined hour and a half. But that hour and a half represents something like 220 million total core CPUs and about 60,000 hours of calc. So again, big numbers, as little as 3 years ago, unachievable numbers. But again, today we won't be at 60,000. I mean, today I'd suggest we're probably going to be at about 200,000. So it's that sort of number and that sort of scale that this has enabled for us. So I take this as a microcosm. As Nidhi said, the bank is doing a lot of work in many, many different areas. This is one that I'm personally quite proud of, given that it's nearly 10 years in the making, and one that hopefully you found interesting. So with that, I'll pass along.
Thank you, Dalton. I appreciate it. Like Nancy mentioned, there are scenarios that are unprecedented where you have to do risk modeling at a scale you have never done. And this is where the power of cloud really shines, whether it's the events of the world today or in general, how the world is going on right now. I feel like HPC has always been in the forefront for many different reasons, whether it is trying to figure out, the things around global climate change. In the last 2 years, we've talked a lot about COVID. Our researchers have always been in the forefront of trying to find the best cure for it, the causes for it, and all of that research. At Microsoft, we have tried to do our share of this, whether it is through research grants, through the AI for Health Foundation, or really borrowing our expertise and our infrastructure and making that available to researchers through the COVID HPC consortium. What I'm really excited about, though, is that in all of this, we enable new use cases that were not possible before at all. And one of those examples is the company called Sensai Health. So Sensai Health is 15% owned by UK's National Health Services. They really create a harbor between pharmaceuticals and healthcare system. In the beginning of COVID, when there was a lot of uncertainty around COVID, the UK government wanted to make sure that they could read the tests that were coming through. There was a lot of errors that were involved when you're reading a lateral flow test with human eyes. And there was errors because human beings were being asked to read, and there wasn't a very scalable solution at this time. This is where UK's National Health Services envisioned an app that could read COVID-19 tests at scale and more accurately. This is where Sensai worked to actually develop that application with us in a very quick turnaround time. We worked closely with them using the power of AKS on our NVIDIA GPUs to help them scale more cost efficiently and get fast results. They were able to use AML to predictably spin up infrastructure when they need, and we use Cosmos DB for storing those test results. Overall, with our work with Sensai Health, we were able to service hundreds of thousands of tests a day. Now they're able to scale up to 30 to 40 million per week. I'm really excited to talk about this use case. And today, I'm joined by Alan Payne, who is the CIO for Sensai Health. Alan, thank you for joining us. Before we turn over to Alan, can we roll the video real quick, please?
Magnify is a solution which allows you to turn a phone remotely into a diagnostic tool. We examined multiple GPUs that were available to us under the Azure cluster. The one which gave us the most advantage was the Triton inference engine.
If we hadn't had a similar technology offering from Azure, it would have been really difficult to achieve what we have done.
Alan, you want to just talk through your experience with Azure?
Yes, of course. So first of all, thank you to Microsoft for asking me to talk. I've been humbled to work on this project, quite frankly, with a very talented team. So to give you some context, in late 2020, we were asked by the NHS, among several other companies, to look at how could we solve a particular exam question, which was, can a mobile phone be more accurate than a human eye in reading a lateral flow test? And the problem statement was actually quite profound, because on that statement, you've got a very variable nature of the human. We're all very different. Human eyes, human brains, how we interpret things, lighting conditions, aspects of fraudulent behavior. There's a lot of different aspects associated with that. So very difficult question. We were lucky enough to be chosen from those companies based on our approach of using machine learning on Azure. And as we went through the requirements of a sub 2-second response time, dealing with a certain number of transactions per second, we realized this was a high performance problem as well as a machine learning problem. And it became quite a multifaceted issue. Luckily, with Microsoft's help, and I've really got to commend the solution architecture teams in this, who not only realized that the problem they were facing was fairly significant and multifaceted, but also to bring in graphics specialists from NVIDIA themselves to come in to help support the problem, the solution for that. In addition to that, if that wasn't enough, we had to support a regulatory framework. So this has to be a medical device, not for professional use, but to support self-testing at home, which is really where the problem lied. You can't scale humans very well, but you can scale electrons, you can scale technology a lot more efficiently. Excuse me. So to meet that regulatory framework, we worked very closely with the MHRA and the National Health Service to realise what was needed and how we could support that. So the technical challenge was around delivering power at scale under a cloud-only architecture. The NHS themselves ran an AWS environment, so we had to integrate to that through an API. And in fact, when we looked at the technology available to us, we realized that we cannot actually run it efficiently within an AWS environment. I'll come on to that in a minute. So our performance started off at running purely on CPUs, where we could only reach 1 or 2 transactions per second on a multi-core CPU. And through our iterations with Microsoft and NVIDIA and our own teams, we realized that we could actually scale that with a combination of GPU and CPU, and eventually to pure GPU based on the NVIDIA architecture. And to give you some examples, we went from being able to deliver about 2 or 3 transactions per second to 10 transactions per second. And eventually we ended up in our production environment where we can deal at the time with 35 transactions per second. And I'm pleased to announce that as at today, we can run over 3 million transactions per day on a 2v2 core GPU system. And the 2 VMs that we associate with those are purely for resilience. So if one fails, the other one automatically kicks in. And that means that we can have 99 point whatever number of 9s you need after that across the backup platforms as well. So it's incredibly resilient. We meet a 2-second service level agreement with our customers. And not only that, we're actually seeing roughly 500 millisecond response times. So we're even exceeding our service levels by a factor of 4. So we're very happy with that. We're happy with the performance. We're happy with the resilience. And again, could not have been done without the partnership with Microsoft and with the NHS to help deliver that. So what about some of the results from this? Well, the exam question, if you recall, was, were we more accurate than the human eye? And I'm pleased to announce we are. We're independently verified to be 24% more accurate than the human eye. And the reason is that we are more objective than these pesky humans that have lots of variation in their ability to detect things. We've also enabled a regulatory approval. We were the first company to be offered a derogation for use in the UK for home test use, which was remarkable, and it also allowed us to use the lateral flow tests in care homes, domiciliary care, and in the NHS themselves in a multitude of different settings. So we've helped at a national level, both with logistics and to be able to support, quite frankly, millions of people through their daily lives. And we're currently supporting that level of performance and accuracy. So delighted again with the partnership. We could not have done it without you, and a heartfelt thank you for working on a really noble project that we're grateful to have helped at a national level. So with that, thank you for your time. I'd like to hand back to Nidhi.
Thank you, Alan. I really appreciate your kind words and all the work that you are doing. It's very humbling to be a part of this journey. And it also really want to underscore the points you made around partnership. And this is where I think our key differentiation is really around partnerships. And this is where I extend our partnerships even to our ecosystem partners, whether it is, looking at our ecosystem partners, such as our ISVs, such as our schedulers, our AI frameworks. Azure wants to be have a rich set of ecosystem partners. And this is where, whether our ISVs want to have their own curated cloud, whether they want to go through a lift and shift of our experiences, we work very, very closely with our ecosystem partners to make sure that they actually have a rich experience on that. And thereby, we want to make sure that our customers are able to do their productivity, they're able to do their applications quickly from what they were used to on-premise onto cloud. And this is where the underlying theme is partnership. And to further our partnership in here, I actually want to invite Preet Banerjee, who's the CTO from Ansys, to talk a little bit about our partnership with Ansys that we have matured over the last many years and see how that has been going on. Preet?
Thank you very much. So thank you very much for inviting us to speak. So as Nidhi mentioned, right? So we are absolutely pleased to partner with Microsoft. What Ansys does is we do computer-aided engineering simulation. The world around us is governed by the laws of physics, right? Physics such as Navier-Stokes equations for fluids or Maxwell's equations for electromagnetics. And we take the physics, solve it numerically using numerical methods like finite element methods and so on. And these problems typically run on workstations, and increasingly they're running on high-performance clusters on-premise. Now we have partnered with Azure to take all these solvers on the cloud. And I want to kind of talk about what we have done, for example, with a customer such as Van Oord, right? So we partnered with Van Oord to take their problem of wind turbine sort of designs, right? And we facilitate them to do wind turbine design. Now, they had this problem that they were running their simulations, right, in the product development time, right? Each run would take 150 hours. Now, of course, they could buy a HPC cluster on site, but that is, as Nidhi mentioned, right, it's kind of really expensive. And then what they needed was a cloud bursting capability. So we partnered with Van Oord to provide them, working with Ansys Cloud, right, on Azure to speed things up to run it in 24 hours, right? So this 5x kind of speed up enabled them to provide significant sort of financial capability and so on to rapidly do product design. So I kind of want to talk about a few technologies that has enabled us to really leverage the partnership with Azure. So first of all, HPC. Nidhi talked about HPC. All our solvers such as Fluent for fluid dynamics, or mechanical for finite element methods, or numerical for photonic simulation, right? They are leveraging HPC at different levels. At the highest level, to do parallel parametric analysis, then we do domain decomposition, then we do parallel loops scheduling, and the finest level we do SIMD parallelism with GPUs. So the top right is showing our Ansys Fluent code, our leading commercial fluid solver, scaling up to 200,000 codes. Very, very difficult to do for commercial codes. But the most exciting result that I wanted to share with you is we have been doing some work on GPUs using our Ansys Discovery Live Solver, but that was running on only a single GPU. What we combined is the work on Fluent combined with Discovery Live to do a multi-GPU fluid solver, which is shown on the bottom right, which is getting like 32 times performance over a 80-core Intel Skylake processor. So that's the kind of speed up that our customers are seeing on HPC. The other thing I want to highlight is our work on AI and machine learning. And we all know that with AI ML, what you have to do is to do training of these neural networks, right, on lots and lots of data sets, and then the neural network learns, and then it performs the inferencing. Now, the problem with engineering simulation is that the number of unknowns is huge. We are talking about 300 million, 1 billion, 10 billion unknowns, right, degrees of freedom. So to train a neural network that has that kind of unknowns is very, very hard. So what we did recently is an example. We came up with this ML-based flow solver, which takes a large patch, breaks it up into 8 by 8 by 8 regions, learns the compressed representation, right? And using that, we have been able to get an ML-based fluid solver, which runs 30 to 40 times, as is shown on the external flow example. A third example is that of using digital twins. Again, we are partnered very strongly with Azure IoT. And what we have done is taking a digital twin is a digital representation of a physical asset. People normally use data analytics-based approach to build digital twins. What we have done is partnered with Azure or with Microsoft, right, to say, take our physics-based simulation and you combine that with data analytics, right? And it can, these hybrid digital twins increase the accuracy of predictive analytics from 80%, which is done through pure data analytics, to 90% through simulation-based digital twins, to 98 to 99% with hybrid digital twins. So we are very excited about the partnership with Microsoft Azure in providing digital twins to solutions in various industries. And I'm going to wrap up with talking about sort of the future of engineering, right? In the product and manufacturing industry, it is the confluence of CAE simulation combined with AI ML, right? Powered with Azure ML, with HPC on the cloud, again, powered by Azure, and building digital twins. And we are very excited about the partnership with Azure. Thank you very much, Nidhi.
Thank you so much, Preet. I really appreciate you joining us today and bringing these key insights. I realize we're running out of time here, so I just want to wrap this session together. Hopefully, as we went through this journey together, you got to see that at Azure, we are really invested heavily in the future of HPC and AI, and we will continue to bring new capabilities, whether it is in IoT, in AI, and quantum computing. Our goal really is that we want to become not just ready for what you need today, but also for your future requirements. And we want to make sure from a developer point of view, your developers don't have to worry about the applications and they focus on just innovation that they are doing in science. Technology in the public cloud is moving very, very fast, and we want to make sure all of that goodness can be brought to our customers quickly. Last is trust. And trust is very important. Here at Microsoft, we have an underlying theme that the world works on trust. We spend $1 billion a year on cybersecurity. We have 3,500 cybersecurity engineers that are constantly monitoring data for threats. And of course, compliance. We are actually very focused on compliance certifications around the world. Ultimately, our goal is that when you think about scaling your workload and thinking about making the next generation of applications available, you think about Microsoft Azure and the power of cloud to really scale your applications. With that, I really appreciate you joining me today. I also thank everybody who was able to join us today, Nelson, Alan, and Preet. I really appreciate you joining us today. For folks who want to learn more about our offerings, some of our results that we shared, here's some of the links that we have made available with all of the content. With that, thank you so much for coming and joining us for this first session. Next up, here you will hear from Vijay and Sherry from my team that will talk about Microsoft Azure's AI infra strategy. Thank you.